Good morning, one and all. I welcome everyone for webinar Emerging Trends, Challenges and Opportunities in Internal Combustion Engine. This webinar is being conducted by the Department of Mechanical Engineering, St. Anne's College of Engineering and Technology, Pandurti. It is my privilege to introduce resource persons, Dr. G. KARTHIKEYAN. He is working as Assistant Professor, Mechanical Engineering, Annamalai University. He had completed BE Mechanical Engineering, MBE Energy Engineering and Management, and PhD in IC Engineers. He has 17 years teaching experience and 15 years research experience and 2 years industrial experience. He had published 17 international papers and 2 national papers. On behalf of management, principal, Department of Mechanical Engineering, and my own behalf, I very much honored to welcome our resource person, Dr. G. KARTHIKEYAN. Welcome you, sir. Next, I sincerely welcome all the participants for this 5 days webinar series. I request all the participants to stay back online throughout session. Now, I hand over the session to resource person, Dr. G. KARTHIKEYAN. Thank you.
Thank you, sir. Now, a very good morning to one and all present here. First of all, I thank the organizers from Department of Mechanical Engineering, St. Anne's College of Engineering and Technology, the principal and the management for giving me this opportunity. And coming to the topic, now we are going to see emerging trends, challenges, and opportunities in internal combustion engines. This is my presentation outline. Majorly, we are going to see 3 topics. One is trends for future powertrains. Other one is advancements in IC engines. And the last one is challenges and opportunities. Now, first, we are going to see mega trends for future powertrains. Now, if you take that trend for future powertrains, it is going to be divided into 2 categories. One is energy diversity. Another one is efficiency and emission. Now, first, we are going to see energy diversity. Now, what is energy diversity means? The use of resources to supply energy to the customer that are produced in such a way that decrease the risk of adverse fuel price changes through a mix of energy resources using a variety of fuels. Therefore, we are going to have some variety of fuel for IC engine. What are the varieties of fuel? We are going to see it now. Now, here the first one. This is the conventional fuel, petroleum-based fuel. Now, it is going to come under the from crude oil, right? Now, the next one is the alternative fuels. It is going to be ethanol, methanol, like that, and biodiesel, CNG, LPG, all comes under alternative fuels. Now, the other source is electricity. Now, we are going to have electrical vehicles. And the last one is the hydrogen energy. We are going to use hydrogen as a fuel for our powertrains. Now, these are all the sources, energy sources we are going to have for IC engines. Now, we are going to see what are the energy resources we are going to available for IC engine means. Now, normally we know the energy resources are divided into 2 types. One is non-renewable, another one is renewable. Now, we are here fossil fuel. We are using oil for our IC engine. Another type is nuclear fuel. Another is renewable fuel such as hydrogen gases. Next, we are going to see the world liquid fuel production and consumption. Now, this curve shows the world liquid fuel production and consumption. Here we have the time duration. Here it is the volume, that is million barrels per day. Now, here this blue line shows the world production. This brown line shows the world consumption rate. Now, you can see clearly here the second quarter of 2020. Now, we are in a pandemic situation, that is COVID-19. Therefore, we have a deep decrease in the fuel consumption and also in the fuel production. Now, we can see that here also, this is the stock. We are not using here, therefore, we have stocked it. Now, what is the main thing you are going to get from this slide is, now we are seeing the average energy consumption, fuel consumption. Now, you see here, the average consumption is in between 95 to 100 million barrels per day. For an example, you can take 100 million barrels per day as the average consumption. Now, the next one is how much do we have left of the world resources that we are going to see. Now, this curve shows the future energy resource for 3 things. One is coal, another one is gas, and another one is oil. Now, this shows here, this is oil, this is gas, and this is coal. Now, from the previous slide, we have that 100 million barrel per day. We have the energy consumption. If you go in that rate, we are going to have the oil resource approximately up to 2050 only. Now, beyond that, we do not have any oil source for IC engine. Therefore, this criteria is the main problem for us. Therefore, we want the energy diversity. We want to mix the resources we have. Therefore, this is the main criteria for energy diversity. Now, the next we are going to see what is the vision for us? What is the vision for our automotive industry? Now, here in the x-axis, we are taking the energy diversity, that is the conventional fuel, alternate fuels, electricity, and hydrogen. Now, in the y-axis, you are going to have the improved vehicle fuel economy and emission. If you are doing this, you are going to displace from petroleum fuel, right? Now, we are at this stage. We are at this box stage. Now, what we have here is IC engine and transmission improvements, and we have hybrid electrical vehicles. Now, we are at this stage. Now, what is our vision means? We want to be an electrical vehicle which is based on battery or which is based on hydrogen fuel. These are the future vision of our automotive industry. Now, next thing we are going to see the powertrain efficiency. Now, when you are coming to the efficiency, right, how we are going to increase the efficiency means we are going to reduce the fuel consumption. But that is not only the case. If you want to reduce the fuel consumption, at the same time, you want to decrease the emission also. Without decreasing the emission, if you are decreasing the fuel consumption, it is not suitable. Therefore, we want to increase the efficiency and we want to decrease the emission. That is the main thing. Now, we are going to see what are the emission norms we are having in our country, that is in India. Now, in India, we are following the emission norm as Bharat stages. Now, as we know, from 2017 onwards, we are at BS4. BS4 stands for Bharat Stage 4. Now, from April 2020, now we are at Bharat Stage 6. Now, Bharat Stage 6 is the most advanced emission standard for automobiles, and that is equal to Euro 6 norms. We are just make the BS6 norms equal to Euro 6 norms. Now, what is the main thing here is, from BS4, we just jumped on to BS6. Why this is happened here is, we know what is the problem in our major cities. Now, like Delhi, we have a huge amount of vehicle pollution there. Therefore, our government just leapfrog from 4 to 6. Therefore, we have BS6 norms from April 2020. The main thing we are going to see here is, now all the two-wheelers in India from April 2020, all the two-wheeler manufacturers are manufacturing their two-wheelers using fuel injection system. So what implies we do not have any carburetor in our system, in our two-wheeler hereafter. We are having only fuel injection system. This happens after April 2020 only. Before that, we have carburetor vehicle fuels, that is in BS4 norms. Now in BS6 norms, we have only fuel injection system. This is the main thing we want to have in our mind here. Now, when you are coming to the Bharat Stage 6 norms, it has norms for fuel and also it has norms for emission. Now, we are going to see what is the norms for fuel and what is the norms for emission. Now, if you take the fuel category, now as we have the diesel and petrol, now when you are comparing BS4 and BS6, now we want to reduce 80% of sulfur content in diesel fuel according to BS6 norm. Similarly, when you are coming to the petrol fuel, again here also we want to reduce 80% of sulfur content in petrol. Similarly, 80% of lead quantity in petrol. This is the fact we are going to have for fuel in BS6 norms. This fuel is supplied from April 2020 onwards. Now, when you are coming to the emission, we have different categories in it. Now, we have light vehicle category, we have heavy vehicle category, but commonly we are seeing here. Now, this is your petrol engine norms. Now, we have all the norms, BS3, BS4, and now this becomes BS6. Now, when you see the petrol engine norms, now there will be no change in CO. Already in BS4, we are same value, and BS6 also we have same value. Similarly, for HCC also, we have no change. The main concentration is NOx and particulate matter. Now, for NOx, now in BS6, we are at 0.08. Now, we want to reduce it to 0.06. When you are coming to particulate matter in BS4, we do not have any norms. But for BS6, we want to reduce particulate matter up to 0.005. This is for a petrol engine. Now, when you are coming to the diesel engine, now here also we have no change in CO. Similarly, we have change in NOx. In BS4, we have 0.25, and similarly in BS6, we are going to be reduced up to 0.06. Similarly, HC plus NOx, already it is in BS6, it is in 0.3. Now we want to reduce it to 0.17. Similarly, for particulate matter, already we are at 0.025. Now we want to be at 0.005. This is the norms we want to follow for BS6 emission standards. Now, for following these standards, now we want to improve our vehicle by increasing the efficiency and by reducing the emission. Now, what are the technologies we have that we are going to see to achieve maximum fuel economy and minimum emissions by using technologies? Now, what are the technologies we have? This is the four main technologies we have. What are they means? Charge boosting, charge dilution, active sensing, and electrification. These are the main focus of main focus in future of the advancement in IC engine. Now we are going to see one by one. Now we are going to see in the category advanced IC engine. Now we are going to see the first category, engine downsizing and charge boosting. Now the first category, engine downsizing and charge boosting, from the name itself you can easily understand what we are going to do. We are going to downsize the engine. That is going to, we are going to reduce the size of the engine. For an example, you can see here, this much amount of engine now is going to be reduced to this much. Now that is the principle we have. We want to reduce the engine size. But what is the main thing in our mind is, while reducing the engine size, we want to maintain the power. Now for this, it is 200 HP. Similarly, we are here also, we have 200 HP. That is the main thing. While doing downsizing, we want to maintain the power capacity, right? We are, without affecting the power, we want to reduce the size of the engine. Now we are going to see what are all the factors we are having to reduce the engine size. Now these are all the factors, right? First, we want to reduce the number of cylinders, and then we can add or we can attach a turbocharger or a supercharger to our engine, and we can convert the system into a fuel injection system. These are the measures we need to downsize the engine. Now the other category we have here, what is that? This is charge boosting. Now what is charge boosting means? We are this adding the turbocharger and supercharger becomes the charge boosting. Now we are going to boost the charge. That is the meaning for this. Now for take an example, this is a 3-liter engine, volume is 3 liter, V6 engine. This represents a V-shaped engine with 6 cylinders. This is a non-turbo engine of a capacity of 200 HP. Now we want to downsize this engine to 2-liter engine. Now this engine, this 3-liter is downsized to 2 liters. Similarly, the cylinder, now the first measurement, right? The first thing, reduction of number of cylinder. Now here it is 6 cylinder. Now it is reduced to 4 cylinders. We are reduced to 4 cylinders here. And we are going to add the turbo, right? We are going to boost the charge. Here is the turbocharger. Now, by downsizing like this, we are not changing the power. That is the main criteria here. Now, what are the challenges we have here while doing downsizing means? Now, if you go for fuel injection system, we need a precise fuel control system. Now, we want to inject fuel. Therefore, to inject the fuel, we need a precise injection control system. The next one is, since it is a fuel injection system, we need a precise high pressure fuel pump and an injector. Similarly, when you are downsizing, right, we want to have the engine components in such a way that it must withstand high thermal and mechanical load. Therefore, the engine components must be manufactured, or the components of the engine component have the materials to withstand high thermal and mechanical loading. This is the main criteria of main drawbacks, challenges and needs we have in engine downsizing. Now here, you are going to see the trends followed by different countries for engine downsizing. Now take for an example, USA. Now they are in 3.6. Now they are downsized their engine size to 2.9 liters. This is the trend they are follow for up to 2020. Now they are downsized the engine from 3.6 liters to 2.9 liters. Similarly, we have some other countries. Now this curve is going to show the boosted and non-boosted vehicles. We have manufactured by the different manufacturers. The red thing shows the boosted vehicle. The yellow thing shows the non-boosted vehicles of different manufacturers in the world. Now the next thing is what we are going to charge boost the engine. Therefore, we are going to use either a turbocharger or we are going to use either a supercharger. Now, what this thing going to do is both compresses the airflow into the engine. That provides more power to the engine. By adding this, we are going to compress the air and we are going to give more dense air to the engine, which helps the engine to give more power. Now, first thing we are going to see what is the difference between these two things. What is a turbocharger and what is a supercharger? Now, when you take the turbocharger, now the first point is it's used exhaust stream for its energy. Therefore, the turbocharger is going to operate by using the exhaust energy we have available at the engine exhaust. Now, since it is using exhaust energy, it is not directly connected to the engine. It is not connected to the crankshaft. Therefore, here it is used exhaust steam. Therefore, we have some smoke altering equipments in it. Therefore, we are going to reduce the carbon emissions here in turbocharger. Now, what is the spinning rate means? It is going to a maximum. It is going to revolve at 15,000 RPM. This turbocharger. Now, other point is now since it is not connected to the engine, it is only operated to the best at the high speeds only. At low speeds, we are going to have less exhaust steam. Therefore, it is not operated effectively at low speeds. Similarly, the last point, since it is directly connected to the exhaust stream, it is not easy to maintain. The turbocharger, it is not easy to maintain. Now, when you are coming to the supercharger, now this supercharger is directly connected to the crankshaft to get the energy. Here it is not connected. Here it is directly connected to the crankshaft. Now, this is directly connected. Now, it is directly connected to the crankshaft. Therefore, we do not have any smoke altering equipment. Therefore, we have smoke at the exit of the supercharger. Now, we can compare the RPM. Now, turbocharger is only 15,000 RPM. Now, the supercharger, the maximum RPM is up to 50,000 RPM since it is directly connected to the crankshaft. Now, it can able to deliver their boost at lower RPM since it is directly connected to the crankshaft. It can deliver at any speeds. Now, since it is not directly connected to the exhaust system, it is easier to maintain. Therefore, you can go according to your wish. You can go either turbocharger or you can go supercharger to give the charge boost to the engine. Now, the next thing we are going to see what is the principle of the turbocharger. Now, the main component of the turbocharger is you are going to have a casing. Inside a casing, you are going to have a turbine and a compressor. Both this turbine and compressor are interlinked. Therefore, how to place this turbocharger means now we are going to place this turbine part. We are going to place in the exhaust stream, and the compressor part we are going to place in the intake stream. Now, how it operates means when we have exhaust stream, when we have at exhaust stove, we have exhaust stream. Now, this exhaust stream is going to rotate this turbine and it will go soft. Now, when you rotates the turbine, automatically the compressor is going to rotate since it is interconnected. Now, therefore, this compressor is going to draw air from the atmosphere and it compressed it and it is given to the intake stream. Now, what is the main thing you are going to see here means now while compressing, we are increasing the pressure. Now, while increasing the pressure, the temperature is also going to increase. Therefore, we need a charge air cooler here, right? This charge air cooler is going to reduce the temperature of the air, goes inside the intake port of the engine. Now, this is the basic working principle of a turbocharger. Now, the next we are going to see the working principle of a supercharger. Now, here you can see the engine is directly connected to a crankshaft by means of a belt. Here it is the exhaust stream, it goes off. Therefore, this supercharger is going to means of a belt. From this animation you can get. Now you have the belt drive here. From the crankshaft, it absorbs the energy and this is going to operate, the supercharger. Now, the same principle, it is going to absorb energy from the atmosphere, air from the atmosphere, and it is going to compress and to reduce the intake air temperature, we have a charge cooler and we are going to give it to the intake side of the engine. The process are same, only change is here we are getting power from crankshaft, in turbocharger we are getting power from exhaust. This is the main change. Now, next we are going to see what is the benefits of the charge boosting. Now, for an example, we are going to take a charge boosting in a diesel engine, that is a turbo diesel engine. Now, if you are using a turbo diesel engine, we have a great driving experience with 30 to 50% of mileage when compared to a gasoline engine. Now, for an example, we are taking an engine which is going to have 2.3 liters, 5-cylinder engine of power of 150 And for fuel economy, if you check the fuel economy at city side, it is going to be 18. Fuel economy at highway side, it is going to be 32. Now, this engine is going to be charge boosted by means of a turbocharger. Now, this engine becomes, now this 2.3 liters is going to be downsized to 1.9 liters. Now, how this happened? By means of the turbocharger. Now, 2.3 becomes 1.9. But the cylinder size, reduction in cylinder size. Here it is 5 cylinder. Now, here it is a 4 cylinder. Now, when you're comparing the power value, now we are maintaining the same power. Here it is 150, here also it is 150. Now, coming to the fuel economy. Now, fuel economy at city side, already it is 18, now it becomes 33. Now, fuel economy at highway side, already it is 32, now it becomes 54. Now, what is the effect of turbocharger here? Now, you can see. Now, at the city side, we have 80% of increase in fuel. At highway side, we have approximately 70% of increase in mileage. Now, this is the effect of your turbocharger in our system. Now, coming to a diesel engine, coming to a petrol engine. Now, if you attach a turbocharger to a gasoline engine, it will give 10 to 20% better mileage compared to a non-boosted engine with equal or a slightly better performance. Almost it is going to be equal in most cases. Now, for an example, you are taking a BMW engine. Now, it is 2.8 liters engine. Already without turbocharger, it is 2.8 liters. Now, if you see HP, it is 184 HP. Now, if you see the torque, it is going to be 175. Now, when you're seeing the fuel economy at city side, without turbocharger, it is going to be 19. At highway side, it is going to be 27. This is the case without a turbocharger. Now, we are going to add a turbocharger to the gasoline engine. Now, this 2.8 liters is going to be downsized to 2 liters by adding a turbocharger. Now, 2.8 becomes 2 liters. Now, when you compare the HP, now already it is 184, now it becomes 205. We have more HP here instead of having a less volume. 2.8 becomes 2 liters, but we have a higher HP, 205. When I compare the torque, it is already 175, now it becomes 209. Similarly, when you compare the fuel economy, now fuel economy at city side, already it is 19, now it becomes 23 when you have a turbocharger. Now, fuel economy at highway side, already it is 27, now it becomes 33. Now, what is the effect we are going to see? Now, here we have 10% increase in HP, 20%, almost 20% increase in torque, and a 20% increase in fuel economy if you add a turbocharger to a gasoline engine. These are the benefits of charge boosting by using either a turbocharger or a supercharger. Now, the next thing, the advancements in IC engine is a fuel injection system. Now, we want to replace the carburetor by a fuel injection system. Now, the function of carburetor, as we know, the carburetor alone can control the airflow into the engine and also the fuel flow into the engine. Both the process is going to be taken care by the carburetor, but in the injection system, we want to control it separately. Now, we are going to see what are all the fuel injection system, what are the process we want to done to convert a carburetor engine into a fuel injection engine. As I already told, right, we need two systems. One is for air control, another one is for fuel control. Therefore, for air control, we are going to have a air supply system, which is going to be called as a throttle body, and we are going to have a fuel supply system, which is going to have a fuel injector, a controller, a fuel pump, like that. We are going to have a fuel supply system and also a air supply system in the fuel injection system. Now, for the presentation purpose, for the demonstration purpose, I am going to show you the alterations made in a Royal Enfield 350cc engine. This is the engine I am going to use in my PhD work. Now, for a presentation purpose, I am going to show you the figures of this 350cc engine. Now, when you're coming to the air supply system, we want to see what are the main components of the air supply system. Now, the main components are a air filter and a throttle body. Now, these are all the main components of the air supply system. You can see photographically, this is the air filter and this is the throttle body, two side views of the throttle body. Now, how you control air here means, now in this, inside this throttle body, we are going to have a throttle plate. Now, by operating the accelerator, we can open or close the throttle plate. According to the position of the throttle plate or according to opening of the throttle plate, we are going to allow the air inside the engine. Therefore, the air control is taken place here by means of a butterfly valve in the throttle body. Now we have to sense the position of the throttle plate. We have a throttle position sensor, and to sense what is the magnitude of the intake pressure. We have a manifold pressure sensor. These are the sensors we are going to have in the air supply system. One is a throttle position sensor. Another one is the manifold pressure sensor. These are going to be used in the engine control units. Now, this is the photographic view, assembled view of the air supply system in the Royal Enfield 350cc engine. You can see here, this is the throttle body with all the arrangements. Next, we are going to see the fuel supply system. Now, in the fuel supply system, the main components are a fuel tank with the fuel pump. We are going to have a fuel tank with the fuel pump, fuel lines, and a fuel regulator, and a fuel injector. To control this, to operate this fuel injector, we are going to have a control unit. Now, as you know, this pump is going to deliver the fuel and through these lines to the fuel injector. Now, what is the necessity of the fuel regulator here means the capacity of the pump, the output capacity of the pump is 5 bar pressure. It is going to give the fuel at 5 bar pressure. But our injector, most of our injectors are operated at 3 bar pressure. Therefore, this fuel regulator, what we have in our line, is going to regulate the pressure. It is going to give only 3 bar pressure to the fuel injector. Remaining, it will be bypassed again to the fuel tank. Therefore, this is the main purpose of the fuel regulator. Without this, we can operate the engine, but the life of the injector is going to be reduced. Since it is its capacity is only 3 bar, if you apply 5 bar, the fuel injector will be it is going to be damaged as early as possible, right? Therefore, this is the fuel supply system we have in our fuel injection system. Now, the next thing you are going to see a fuel injection test bench. Now, why we are going to have this? Why we need this fuel injection test bench? That we are going to see now. The same components: fuel pump, fuel tank, fuel lines, a control unit, and we have an injector. Now, what we are going to do here means we are going to place the injector inside a chamber. This chamber is going to be placed over a weighing machine to find how much quantity of fuel. This is how much quantity of fuel we are injected here. Now we can see it here. Now we have the schematic diagram here. Now the fuel is given by the pump to the fuel injector by means of the bypass valve. This control unit is going to control the fuel injection. Now, another important thing you want to see here is now this box. Now the fuel injector in place inside a collecting box, a fuel collector that is going to be placed inside a ice box, a mixture of ice and salt. Why we need this means we are going to inject the fuel in a atomized way, in a fine spray manner. Therefore, if you place it inside the fuel collector in the salt and ice mixture, we are going to reduce the evaporation loss. Therefore, whatever we injected, we can get in the weighing machine. Therefore, this is the circuit we have. Now, the important thing we are going to see here is how to operate this injector by using this control unit. Now, for that, we want to see some terminology, that is terminologies like pulse width, pulse interval, duty cycle, like that we want to see. We are going to see one by one. Now, what is pulse width means? The on time of the injector. We are going to on the injector and off the injector frequently. Now, therefore, the on time of the injector is going to be called as a pulse width, and the on and off time totally, it is going to be called as a pulse interval, or we can call it as one cycle. Pulse interval or one cycle. The main thing is the pulse width. The pulse width means it is going to be the on time of the injector. Now, when you are coming to these diagrams, now for an example, right? Now we are taking, for an example only, we are taking 3 minutes. 3 minutes as a cycle time. That is the pulse interval. We are going to take 3 minutes. Now, in between that 3 minutes, we are going to operate the injector. How we are going to operate? Now we are going to on the injector for 1 minute, and we are going to off the injector for 2 minutes at this diagram. Now here we are on the injector 2 minutes and we are off the injector 1 minute. Now what is in this two diagram means, now by on-ing the injector for 1 minute and by giving a pulse of off signal for 2 minutes, we are having some fuel injection quantity here. When I calculate the duty cycle for this, we are going to have 33%. Now coming to this diagram, now here what is the change? Already we are on the injector for 1 minute. Now we are on the injector for 2 minutes. We are off the injector for 2 minutes here. We are off the injector for 1 minute here. That is the change between these two diagrams. Now what is the main thing is, if you calculate the duty cycle, now the duty cycle becomes 66 for this process. Already it is 33 for this process. Now what it implies, if you change the duty cycle, now you can see for 33% of duty cycle, you are going to have high air and low fuel ratio. Low duty cycle means high air, low fuel ratio. High duty cycle means you are going to have low air and high fuel ratio. This is the main thing you want to see from the duty cycle. Therefore, you want to maintain a duty cycle according to that. Increasing duty cycle will increase the fuel quantity. Decreasing the duty cycle is going to decrease the fuel quantity. From this, we are going to arrive this. Now, this diagram is going to show you effect of pulse width on fuel injector. This curve is obtained from that from this test bench. We are doing some pilot study here. The result of the pilot studies are shown here. Result of the pilot studies. Now, what we have here is, in x-axis we have pulse width in millisecond, and in y-axis we have the quantity of fuel injected in kg per hour. Now, how we get this curve means, now for an example, right, we are operating the injector at different speeds. Now you can ask me how you are operating the injector at speeds, sir. Now I am taken 1000 rpm to 5000 rpm with an interval of 500 rpm. What is the relation between speed and operation of the injector means you are going to see from this calculation. Now first we take 1000 rpm. 1000 rpm means 1000 revolutions per minute. Per minute we have 1000 revolutions. Now first we are going to convert it into, for 1 seconds, how many revolutions we have. From that we are going to convert it for 1 revolution, how many seconds we have. Now for doing the calculation for 1000 rpm, we are going to get 60 milliseconds. Now 60 milliseconds is our pulse interval, that is called the cycle duration, pulse interval, 60 milliseconds for 1000 rpm. Now for an example, the higher side, we are taking 5000 rpm here. Now for 5000 rpm, you are going to have, for 1 rotation, you are going to have only 12 milliseconds. Now the pulse interval or the cycle, one cycle is going to be finished at 12 milliseconds only. Now what we are going to obtain from this, now take for an example 1000 rpm, this is the 1000 rpm curve. Now it is going to be operated at a maximum of 60 milliseconds. 60 milliseconds is our duty cycle. Sorry, 60 milliseconds is our 1 cycle, right? Therefore, we are going to operate 60 milliseconds. Now, how we are going to operate? Either you can on the injector for 10 milliseconds, and you can off the injector for 50 milliseconds. And then you can on the injector for 20 milliseconds, and you can off the injector for 40 milliseconds. Like that, you are going to do the preliminary studies, the pilot studies, and we are obtaining this curve for different RPM. Now, what we are going to get from this curve means, now by using this curve, we can decide. Now, in the market, we have different manufacturers of fuel injector, different types of fuel injectors we have. Now, from this diagram also, we can, this is a Bosch make injector with the 4 holes. Now, similarly, a Bosch make have 2 holes injector. Like that, we have different makes also. Now, we want to test all the injectors, whatever we have in our market in this test bench, and we can arrive the curve like this. Now, from that curve, we can find out the fuel injection rate, which injector suits for our engine. We can find that, and we can choose a suitable injector by doing this pilot study. And now the next important parameter is fuel mapping. The fuel mapping is a very, very important parameter in a fuel injection system. Now we are going to see why it is important. Now take for an example, you are taking a table here. Now we have 3 columns in it. The first column contains throttle plate opening in percentage. The second column contains difference in throttle plate opening in percentage. What is the difference between the first and second? That is given here. Now the third one gives you the on time, that is the pulse width, on time of the injector. Now for an example, right? Now you want to take a case. Why we need this fuel mapping? That we are going to see it now. For a case now, the engine is operating at 1% opening of the throttle plate. Now the engine is running at 1% opening of a throttle plate. Now we are going to change that angle from 1% to 2%. By increasing the accelerator, we are going to increase the throttle plate angle from 1% to 2%. Now what is the change here? When I consider the percentage, it is only 1% change, 1 to 2. It is going to be only 1% change. But what is the change in the air quantity inside the engine? We are going to see it now. What is the change? It is going to be 100%. How I am telling like this? Now, for an example, if you take at 1% opening of the throttle plate, if the engine gets 1 kg per hour, for an example, I am telling you 1 kg per hour. Suppose if you increase 1% to 2%, how much the engine is going to take? 100%. Therefore, it is going to take 2 kg per hour. The change is 100% here. The change of fuel, the change of air quantity is going to be 100% here. This is the lower range from 1 to 2. Now we are going to take a higher range. Now what is the condition here? The engine is running at 90% opening of the throttle plate. We are having 90% here. Now we are going to change again. How much change in percentage? We are going to change from 90 to 91. We have the percentage change is 1%. Here also the percentage change is 1%. But you are going to see what is the change in the air quantity. Here the air quantity change is 100%. But here the air quantity change is only 1%. When you are at lower stage, we have higher change in percentage of air quantity, but in higher stage we have a lower change of air inside the engine. Therefore, this fuel mapping is important. We want to concentrate according to this. We are going to concentrate more, and we want to get this pulse width for the operating the engine. By doing the proper fuel mapping, you can run the engine smoothly in a transient condition. Therefore, the fuel mapping is very, very important here. Now you can see this is the fuel mapping curve I am obtained for my 350cc Royal Enfield engine. Now in that what we have means, now in x-axis we are having throttle plate opening in percentage. In y-axis we have pulse width in milliseconds. Now now we are going to see, right? Now at the earlier stage you can see a sharp increase, and in the later stage you can see a flat curve, a linear curve. Now, what we are going to obtain from this curve is, now you can see here at the lower stage. Now you can see at the lower stage, 0 to 10% of opening. Now, what is the change in the pulse width? Already at 0, you are at 2 milliseconds on. Now in 10 milliseconds, approximately it is 5.5 milliseconds. That what is the difference? Around 3.5 milliseconds. The change here for 10% of opening. Now when you see at the higher stage, 90 to 100. Now at 90 we are at 10.5 milliseconds on. At 100 we are going to have only 11 milliseconds. What is the change here? Only 0.5 milliseconds. Therefore, we are going to do the fuel mapping according to that. This is very, very important parameter. That is fuel mapping. You will not get this detail from any book. This is my practical experience when I am doing my PhD work. You will not get this curve, like this curve, and this calculation you will not get from any books. This is very, very important. Now, the another important unit in our fuel injection system is engine control unit. It is commonly called as ECU. What are the main components? What are the main components you are going to have in the engine control unit is, the main component is a microcontroller and a fuel injection driver circuit. One is microcontroller, another one is fuel injection driver circuit. Now, other thing, we are having some electrical electrical devices to operate the injector. This is the ECU. I am personally made for my 350cc engine. With the help of our Annamalai University E&I faculty students, I made this ECU. Now, this microcontroller, right? It is a Arduino-based controller. Now, what we are going to do with this microcontroller means, these are all the we can give inputs. These are all the input side. This is the output side. Now, what we are going to give as input, we are going to give different sensors. For an example, we can have in air supply system, we have a throttle position sensor, and similarly we can have a map sensor, right? Like that, we can give the outputs of the sensor as input to this microcontroller. Now, we want to preload some programming. We want to write some programming and we want to preload it to this microcontroller previously before giving the input. Now, by taking this input and this program, whatever we have fed inside the microcontroller is going to operate, and we are going to find out the output. Now, the output is given by this port. Now, this is going to be given to our engine operating devices that we can, for an example, you can take fuel injector. We can give the output from this microcontroller to a fuel injector. Now, another question we have in our mind, why we need this fuel driver circuit? Now, this microcontroller, right? This is the heart of the engine. This is going to operate our engine with the fuel injection system, right? The operating voltage of this microcontroller is going to be around 5 volt DC. It is going to operate at 5 volt DC only. The output also you are going to get only 5 volt DC. Therefore, when you check the fuel injector, right? Almost all the 90% of the injector is going to operate at 12 volt DC. Now we cannot straight away feed the output we obtain from the microcontroller to a injector, since it is 5 volt DC. We want to amplify the signal 5 volt to 12 volt. Therefore, the main purpose of this fuel driver circuit is the injector driver circuit is going to be amplifying the signal from 5 volt to a 12 volt signal without modifying the pulse width. Now here the on time and both the side, the on time is going to be same, the off time is going to be same. What we are doing here, we have just increased the magnitude from 5 volt to 12 volt. Therefore, this is the main operation of the ECU. Now, this screen shows you the programming, sample programming we are having for the ECU. Now, we are going to write the program here, and by means of connecting cable, right, by using a system and the microcontroller, we are going to feed this program into the microcontroller memory. Now, when you on the microcontroller, automatically this program is going to execute, and it is going to take the input from the sensor, and whatever we are given here, whatever formulas we are given here, by using that input, the formulas are going to calculated, and the output is going to be given to the output port. This is the main thing. You have to give ECU programming. Now, the next important system in fuel injection is ignition system. Now, the conventional for this Royal Enfield 350cc engine, the conventional system is flywheel magneto pulsar coil capacitive discharge ignition system. Now, this system must be replaced by means of a microcontroller based ignition system. Now, why we need this means, by using this system we cannot alter the ignition timing. Now, we want to alter according to the fuel quantity and according to the operation of the engine, we want to alter the ignition timing, right? Therefore, to alter this, we need this system, microcontroller based system. And another important thing is coil on plug system, COP system. Now, all our four-wheelers have this coil on plug system, but all our two-wheelers have a separate coil for boosting the signal, and we have a fuel injector. We have a spark plug. Now, we are going to see what is a microcontroller based coil on plug ignition system. Excuse me. Sorry. Now we are going to see what is a microcontroller based coil on plug ignition system. What are the main components means? We are going to have a microcontroller. We are going to have a coil on plug COP. We are going to have spark plug, and we are going to have a battery system to operate this. Now, how this microcontroller is going to operate the spark plug means, the microcontroller, as we said, it is going to take some input from the sensors. Now, from TDC encoder, we are going to take the top dead center position as an input to this microcontroller. Now, according to the program given inside this microcontroller, it is going to decide, or it is going to find out where to trigger the COP. Now, according to the position, it is going to trigger the COP. Now, the COP, this coil, is going to give the signal to the spark plug. Now, we are going to get the spark here. Now, this we can alter, right? By adding some other, by adding some sensors, proximity sensor, we can alter the trigger signal according to the signal from the proximity sensor. Now, we are going to see the pictorial view of a microcontroller based coil on plug system. Now, this photograph shows a coil on plug microcontroller based ignition system. I'm having in my research engine, that is a Royal Enfield engine. Now, this is the coil on plug. Now, you can see here, this is a coil on plug. Now, here we have a spark plug. Now, this is connected to the microcontroller. Now, we are going to operate the microcontroller, right? Now, when you are seeing the signals of the two systems, the conventional system and the microcontroller based system, this yellow line shows the conventional system, that is a pulsar coil system. It is giving some extra signals also. It's giving, for each cycle, it is giving a trigger signal. But here, you can see here, now we have the magnitude. We have here only at the point where we need the injection, where we need the ignition. Now you can see it here also, right? The magnitude of the signal of the microcontroller based system and a conventional system, right? Now, the another important thing is the point of fuel injection. Now we want to inject the fuel before before intake port opens, right? Now, therefore, this point of injection is also very, very important in fuel injection. Now we are going to see what is the changes, what are the modifications we made in the engine to get the fuel injection point. Now this photographs shows a conventional timing case for a Royal Enfield 350cc engine. Now this timing case here we are modified. We are taking a camshaft. This we are extended the camshaft. We are here. We are extended the camshaft, right? This shows the diagram. Now this is the arrangement we have. This is the TDC encoder. This is the proximity sensor. One thing is going to be used for fuel injection. Another thing we are going to use for some other purpose. Now you can see in closer view also. This is the TDC encoder connected with the camshaft. Now these are all the proximity sensor we are having for point of injection and other things, right? Now this is the TDC encoder and proximity sensor locations. Next, when we are coming to the types of fuel injection. Now in petrol injection system, we have two types. One is indirect injection system, otherwise called as manifold injection. Now the other type is gasoline direct injection, which is commonly called as GDI. Now this manifold injection system is further classified into single point injection and multi-point fuel injection. Now the single point fuel injection and throttle body injection are the earlier stage of fuel injection. Now we are in this stage, right? Now we are using only multi-point fuel injection and port injection. Now we are going to see what is a port fuel injection engine or a port fuel injection system. Now from the name itself, you can get, we are going to inject the fuel in the intake port. Therefore, we want to place the injector in such a way that it is going to inject the fuel in the intake port. Now you can see clearly. Now this is the intake port. Now this is the exhaust port. This is the inlet valve. This is the exhaust valve. Now this is the injector. Now here you can see clearly. This is the injector. This injector is going to give you fuel to the intake port. Right? This is the port fuel injection system. We are going to see it further here. Now what is the main thing here is the position of the injector, right? The position of the injector is very, very important here. Now why this is important means, now if you place the injector in such a way that if the fuel injected the fuel, if the fuel hits the surfaces, the surfaces of the intake port, what happens is some quantity of the fuel is going to be stick on to the valves, and only some quantity of fuel is going to be get inside the cylinder. Therefore, whatever we injected, whatever flow rate we have here, it is not going to be goes inside the cylinder, right? This parameter is called as valve wetting parameter. Valve wetting parameter, right? To avoid this, right? What is the main thing is to avoid this, we want to place the fuel injector in such a way that when I am giving the fuel injection, the fuel injected quantity is going to hit the intake valve base. This is the main thing you want to have in our mind. You want to position like that. You want to place the injector like that. When you injected the fuel, whatever the fuel injected is going to hit the valve base. What is important in hitting the valve base? Now you can see this valve is going to be directly connected to the combustion chamber. Therefore, what is the temperature of this valve? It is going to be higher, right? Therefore, if you injected the fuel on the valve base, automatically whatever the injected is get vaporized and it will mix with the airflow and it will go inside the cylinder. Therefore, this will minimize, this will reduce, 99% it will reduce the valve wetting parameter. Therefore, the position of the injector is very, very important in the fuel injection system. Now you can visualize it by means of this Royal Enfield engine. Now this is the actual cylinder head. Actual cylinder head we have in a Royal Enfield 350cc engine. Now this cylinder head is going to be modified like this. Now we are filling materials here and we are doing some CNC machining and we are positioning the injector like this, right? Now we are positioning the injector in such a way that it is going to hit the valve base. Now this is the bottom view of the cylinder head, and this is the center hole is going to be the gate for this intake valve, and this is the hole we have made now. Now through this hole only we are going to inject the fuel to the injector valve base. This is the cylinder head modification we need for the position of the injector. Now this photograph is showing you the total arrangement of a port fuel injection engine, SI engine. the carburetor is replaced or retrofitted with the port fuel injection system. This gives you a photographic view with all sensor, ECU and all. The next thing is we are going to the advanced stage, that is a direct injection system. Now, what is the main difference here is from port fuel injection is now we are not injecting the fuel in the port, right? That is the main thing. We are going to inject the fuel inside the cylinder as in the case of diesel engine. While in the diesel engine, we are injecting the fuel inside the cylinder, right? Therefore, like that, we are going to inject the gasoline, the petrol also inside the cylinder. We are going to inject, right? Therefore, what is the main thing here? The position of the injector, right? We want to place the injector such a way that the fuel going to be injected is going to directly goes inside the cylinder. Now, this diagram, you can clearly identify, right? This is the fuel injector. This is the spark plug, inlet valve, exhaust valve, and all that, okay? Now, what is the main criteria I want to see here is, since we are connected directly to the combustion chamber, right? This fuel injector material, we need a precise material. Since it is going to withstand high pressure and high temperature, since it is directly connected to the engine cylinder, right? Therefore, the material of the fuel injector, we want to be precise. Now, similarly, right, we are directly connected to the combustion chamber, therefore, we have high pressure here, therefore, we want to withstand high pressure, and also we want to give a high pressure fuel, right? Then only we can inject the fuel inside the cylinder. We need a high pressure fuel pump. When you compare to the port fuel injection, right? We need a high pressure fuel pump. Those are the main criteria here. Similar, the operation is going to be same. The same 4-stroke is going to be happen, right? We are going to have combustion and we are going to have the other steps, right? This is the direct injection system. Now, the next important system is the homogeneous charge ignition system, commonly called as HCCI engine, right? HCCI engine. Now, we are going to see what is the difference between the conventional diesel and petrol engine with the HCCI engine. Now, this diagram, this shows you the diesel engine and this shows you the petrol engine, right? Now, how you differ? How you tell this is a diesel engine and this is a petrol engine, right? Now, if your engine has a fuel injector, right? Then it is going to be a diesel engine without a spark plug. It is going to be a diesel engine. Now, if you have a spark plug, then it is going to be a petrol engine, right? Now, we are going to see HCCI engine here. This is a HCCI engine. Here, we do not have an injector or a spark plug. We have only inlet valve and we have a exhaust valve. This is going to become a HCCI injector, right? Now, we are going to see how it is going to operate, right? From the name itself, homogeneous charge compression ignition, right? The first part, homogeneous charge. Where we are getting the homogeneous charge? In petrol engine, right? We are having homogeneous charge. We are going to have this mixture outside the cylinder and we are going to feed inside through the intake port, right? Therefore, the homogeneous charge, this is going to be the principle of petrol engine, right? First part, we are going to have the principle as a petrol engine, right? Second part, we are going to have compression ignition, right? That is going to be happen in a diesel engine. Therefore, this HCCI engine is going to be a combination of both the principle, the petrol and the diesel, right? Now, how it is going to operate? Now, as in the case, right? We are going to take the charge inside and we are going to compress, right? How much we are going to compress until the mixture is going to get auto ignites. That is very, very important here, right? We are going to compress until the mixture gets auto ignites. Now, other important thing is we are going to have a lean fuel mixture here. In HCCI engine, by having this lean fuel mixture, we are going to increase the efficiency, we are going to decrease the emission, right? Therefore, we are having a lean mixture here. Now, how the compression takes place? How the combustion takes place here means now by means of auto ignition, right? Now you can see in both these cases you are having point triggered combustion, right? From here only it is going to travel. From here only it is going to travel. But here we have multi points of ignition. Since we have compressed it until it will get ignited, right? Therefore, here we have a low fuel consumption. Therefore, the engine efficiency is going to be high. Automatically, if you have low fuel consumption, your emission is going to reduce. This is the main advantage of a HCCI engine. Now, what is the main disadvantage here is construction of the engine, right? We need more time and we need more strategies to get this construction. That is very, very important here. That is the main disadvantage. That is the main disadvantage of HCCI engine. The next thing, right? Next, we are going to see the active sensing, the second element. Active sensing, we are going to see it now. Now, what is active sensing means you are going to sense inside the cylinder, right? What we are going to sense means the cylinder pressure. How we are going to sense means by using the in-cylinder pressure sensor. We are going to measure the in-cylinder pressure. What is the effect means? By means of this pressure sensor, we are going to control the combustion very smartly, right? Therefore, we are going to sense the inside cylinder pressure using a pressure sensor, right? Now we are going to see in detail. Now these two photographs is showing you how to install the pressure sensor, right? Now this is the conventional photograph. It is going to have a decompression lever here, right? A decompression lever in a conventional 350cc engine. Now this decompression lever is removed in that place by means of suitable attachments, right? By means of suitable attachment, we are installed a in-cylinder pressure sensor, right? Now we removed it and we are included a pressure sensor here, right? Now the main thing you want to have in your mind in the pressure cylinder installation is without altering the compression ratio, you want to install it. If you do any machining in the cylinder head, suppose if you want to make extra hole, right? Now that will alter the compression ratio. Therefore, you want to keep in mind, we want to install the pressure cylinder without changing the compression ratio. That is the important thing you want to have. Next, you are going to see how this is going to operate. Now, this cylinder is this transducer is directly connected to the cylinder pressure. Now, we are going to when the piston moves up and down, it is going to sense the pressure and it is going to store in the system, right? By means of some analog and digital converter. Similarly, we are going to have the crank position with respect to the pressure, right? We are going to store in the system, right? Now, by this way, we have measured the cylinder pressure inside the cylinder. Now, what is the purpose of this means? Because the pressure resulting from combustion of the fuel and air mixture is going to be the important parameter. This is going to give you the torque and power to the engine. Therefore, this is the most fundamental parameter to examine the engine during the early development stage. Now, what we are going to see is the magnitude and time. The magnitude and time of the in-cylinder pressure during compression and power stroke. We want to see the magnitude and time with the help of the in-cylinder pressure sensor, right? Now, these are all the parameters we can measure from the in-cylinder pressure sensor. What we can measure, we can monitor maximum combustion pressure. We can measure IMEP, this is indicated mean effective pressure. We can analyze knock. We can analyze cycle-to-cycle variation. We can analyze what is the heat release rate. We can analyze what is the ignition delay inside. All these parameters we can measure with the help of this in-cylinder pressure measurement. Now, this curve, it shows in-cylinder pressure measurement according to the crank angle, right? In x-axis, we have crank angle. In y-axis, we have cylinder pressure in bar. Now, this zero position is your TDC. This zero position is your TDC. This is before TDC. This is after TDC. Now, what is the two curve shows means? Now, this black curve, a small curve. This is going to tell you what is the motoring curve. Now, what is motoring curve means? Now, we are going to run the engine without combustion. Right? Without combustion, we want to crank the engine. At that time, we are going to sense the cylinder pressure. The curve obtained during that period is called the motoring curve. Now you can see the maximum pressure at the exact TDC. Right? What is the maximum pressure? Around 5 bar without combustion. Without combustion, right? That is the main thing. Without combustion. Now this curve shows with combustion and at 95% load. Now you can see the pressure difference. The maximum pressure. Without combustion, it is 5 bar only, around 5 bar. Now, at 95% load and with combustion, almost it is going to become 30 bar. This is the maximum combustion pressure we obtained at 95° pressure. Now, the next thing is charge dilution. The important factor is charge dilution. Now, why we do charge dilution means the main thing is we are going to keep only on mind is we want to reduce emission of nitrogen oxides, NOx from ICE engine XR. We don't bother about the fuel consumption or other parameter. By doing the charge dilution, we are going to reduce NOx. That is the main thing. How to do the charge dilution means the principle we are going to call it as exhaust gas recirculation, EGR. This is the principle you are going to utilize in the charge dilution. Now this curve shows you the charge dilution, how much NOx reduced. Now this curve shows without EGR, this two curves shows with EGR. Therefore, you can visibly understand how much NOx is reduced when you increase the percentage of EGR, right? Now we are going to see here the EGR principle. Now here, what is the principle is, now from the exhaust stream, we are going to take some amount of exhaust stream and we are going to mix it with the intake. Now by mixing like this, we are going to dilute the charge. What is dilution? We are going to reduce the CO2. We want to reduce the oxygen content here, right? Therefore, if you reduce the oxygen content, automatically the inside cylinder temperature, right? In cylinder temperature is going to reduce. In cylinder temperature and NOx, both are interrelated. If you decrease the in cylinder temperature, automatically NOx is going to reduce. Now, how much quantity we are going to take from here, right? That is going to be decided by this ECU. This ECU is going to decide how much quantity we are going to trap from the exhaust port by getting the different sensor input, right? Now you have a sensor in the intake and you have a sensor in the exhaust. I think these are all the temperature sensor, right? Now by getting this input signal from the sensor, this ECU is going to determine how much quantity, how much percentage you want to take from exhaust and you want to mix it to the intake, right? Now this is the principle of EGR. Now by using this EGR, we can go for charge dilution, right? The main disadvantage here is, now we are concentrate only on emission here. We are not bothered about the performance, right? We can reduce NOx emission by using this EGR principle, right? The next thing is electrification. Now the future mobility, right? The future mobility depends on electrical vehicles. This is the main thing we want to have in our mind, since we know our oil resource is up to only approximately 2050. Therefore, we want to move to electrical vehicles. That is our future mobility. Therefore, these electrical vehicles are driven by electrical motor. And main thing you want to have in your mind is this electrical energy you want to derive from green energy such as solar power, nuclear energy, etc. Right? You want to charge the system, or you want to utilize green energy, or renewable energy sources to charge the battery or to run the vehicle, the electrical vehicle, right? What is the main thing here is, we are not going to have any combustion, therefore we are going to have, we do not have any emission here, therefore it is a green vehicle and it is going to reduce the dependency of the oil, right? This is the main thing we have in electrical vehicles, right? Now, how the electrical vehicle is going to operate, that we are going to see. Now, this electrical vehicle is powered by electrical motor rather than an engine, right? We are going to have an electrical motor to run the engine, to run the automobile. Now, this electrical motor is going to powered by means of a controller. This controller is going to give the power to the DC motor. Now, this controller is powered by means of array of a battery, right? Now, here we have array of a battery. Now, this array of the battery is going to give charge to this DC controller. Now, how this operated. Now, when you press the accelerator pedal, this potentiometer is going to decide, right, how much energy this potentiometer is going to give the signal to the DC controller. This DC controller is going to decide how much energy we want to supply from battery to motor, right? According to the energy, this motor is going to give you the power to the wheels, right? This is the main thing you want to have in your mind. This is going to operate in a green manner, since we don't have any exhaust. And another important thing is, we want to charge this battery by means of renewable sources. That is also very, very important in electrical vehicles. You want to charge this battery by means of renewable sources. Now, the important component in the electrical vehicle is already we seen electrical motor and batteries, right? Now, batteries are the main important thing here. Now, what are the types of batteries we have here means, now we have lead acid batteries, we have nickel metal hydride batteries, we have lithium ion and lithium ion batteries. These are three batteries: lead acid, nickel metal hydride, and lithium ion. These are the three batteries. When you're comparing the performance and cost, right? Cost-wise, lead acid battery is cheap when you compare lithium ion and metal hydride. But performance-wise, lithium ion and metal hydride battery is going to give better performance when you compare to the lead acid batteries. Now we need some improvements in this. We have some challenges here: lithium ion and nickel metal hydride battery to improve the performance and to reduce the cost. This table shows you the values, different values, performance under the three batteries. Next, we are going to see the types of electrical vehicles. We have three types. One is plug-in vehicles, another one is plug-in hybrid vehicle, another one is hybrid vehicle. Now, the hybrid vehicle in turn have two types. One is parallel hybrid, another one is series hybrid, right? Now, what is the plug-in electrical vehicle means? This is a system we have in our home, right? We have now, most of the homes we have inverter system, inverter battery system, right? When we have when we are disconnected from the electrical grid, right? We are utilizing the power energy from battery, and we are powered our house, right? The same system, right? We are going to have a battery, and we are going to have an inverter, and we are going to have a motor, right? Now the battery is going to give the charge to the motor, and the motor is going to give power to the wheel, right? Now, what is the main thing here is in which type we are going to charge this system, right? Now here in plug-in electrical vehicles, you are going to use grid electricity, right? Grid electricity we are going to use here to charge the vehicle. When you return back to home, we are going to plug the plug point to any of your electrical slot, and we are going to charge the batteries, right? Now this is called a plug-in electrical vehicle, PEV. Now the next system is plug-in hybrid vehicle. Now what is the main difference here is we have the same system, whatever we have, right? Battery and all system we have, and also we have an engine. Now this onboard engine, right? This onboard engine and generator can run the engine, or it can charge the battery also. That is called hybrid vehicle. We can use battery system to run the engine, and we can use engines to generate power, and we can use it to run the motor, or you can charge the battery like that. This is called plug-in hybrid vehicle. We have both the types. This is called PHEV. Now the last important thing is now our concentration. Most of our automobile is going to be concentrated on hybrid vehicles, HEV. Now what is the main thing here is HEVs are powered by both petrol and electricity. We have engine side, we have battery and motor side. Both the things we have, petrol and electricity. The main difference between the other vehicles is here we are going to charge the battery, right? We are going to charge the battery by means of its braking system, by means of its own braking system. We have some energy while braking, right? That energy is going to be utilized to produce electricity. Now that produced electricity is going to be used to charge the batteries, right? We are not going to charge by using electrical grid, or we are not going to charge by any other source, right? We are going to use their own source. Whatever energy we have here in the automobile, that is called regenerative braking. We are use that energy, and we are going to recharge the battery, right? Then the next system, right? Parallel hybrid vehicle system. Now, what is the main thing here is we have IC engine here, we have motor. Now we can run the engine through IC engine, right? We can run the engine, and we can run the engine by means of motor, and we can run the engine by combinedly, by means of gasoline and by means of motor. We can combinedly run the engine, right? This type of vehicle is called parallel hybrid system. Now, next one is series hybrid system. Now here you can see we don't have any connection between the engine and the drive mechanism, right? Therefore, we can only run the engine by means of this motor. We can run the engine only by means of the electrical motor. We cannot run the engine by means of gasoline, right? We can use this gasoline engine for charging the battery, or we can use the electrical energy to run the motor, right? This type of system is called series hybrid system. Now, this plot is going to give you in what is the vision, how we are going to attain the vision of the automobile. Already we seen the vision, right? Now this curve, right? This part, you concentrate on this part. This is the battery electrical vehicle sales, right? It is increasing gradually. Therefore, our technology is moving towards electrical vehicles. Now the last one in advanced system is hydrogen vehicles. Now, as in the case of electrical vehicles, here also in hydrogen energy also we are going to use electrical motor, electricity to run the engine. What is the main difference here is now this hydrogen car, this hydrogen vehicle is going to have its own power plant. What it means? Own power plant. We are going to produce electrical energy in the automobile itself. We are going to produce energy. Now, how to produce? By means of the fuel cell. We are going to have a fuel cell in the automobile. That fuel cell is going to produce energy. By means of the electrical energy, we are going to run the engine. For producing the energy by using the fuel cell, we are using hydrogen. That is the main thing here. The fuel for this fuel cell is hydrogen. Now, what is the working principle of hydrogen fuel cell means? We are having, as the case, right? We are having a shell. Inside this, we are having anode. We are having cathode. In between, we have electrolyte. Now, at one side, we are supplying hydrogen, right? Now, you can see from this diagram, this is the hydrogen tank. Now, we are filling hydrogen to this tank, right? Now, this hydrogen energy from the tank, it is going to be given here, and it is returned back to the tank. This side, we are giving the oxygen. Where we are taking this oxygen from atmosphere, right? From atmosphere, we are giving oxygen inside. This side, we are going to get water vapor or water, right? Now, how it takes place? Now, at anode side, you can see here at anode side, the H2 is going to be 4H plus and 4E minus. It is going to be separated here at anode side. Now at cathode side, it is going to, all these 4H plus and 4E minus is going to travel here, and it is going to have reaction at cathode side. Now at cathode side we have O2, right? Therefore this is going to be react with O2 and it is going to produce H2O, right? Therefore the only result from this reaction are electrical energy. We are having electrical energy here, heat, water, and which is emitted through exhaust as water vapor, right? This heat and water, this heat is utilized by the water and it becomes water vapor, and we are going to get in the exhaust only water vapor. Therefore it is a purely green vehicle. Now this is the working principle of your hydrogen fuel cell. Now this we are going to be used as a power plant in the electrical vehicle, and we are going to generate electricity and we are going to run the vehicle. This is the future of our automobile, hydrogen fuel electrical engine. The main advantage and disadvantage are, main advantage is quick charging time. When you compare electrical vehicle, this hydrogen fuel system is going to have quick charging time. And the next thing, the range. When you compare the range, hydrogen fuel have longer range when you compare to the ordinary electrical vehicles. Now, other thing is the range of the fuel is not affected by the outside temperature, right? That is the main thing here. It is not deteriorated in cold weather. The same output is given in any weather condition. That is, these are all the main advantages of hydrogen cars. Now, the main disadvantage is the scarcity of refueling station, right? Now, when you take the world, right, at the end of 2019, US only have 40 outlets. German only have 80 outlets, right? Therefore, the filling of hydrogen is going to be scarcity. Hydrogen filling is scarcity. And another important thing is the size of the fuel tank, right? That we are going to see it later. That is a major disadvantage in the hydrogen engine. Next one is, now here in the previous cases, we are utilizing hydrogen to produce electricity. Now here, the hydrogen is directly fed to the IC engine to get the combustion and power, right? Now again, we have port injection and direct injection, and we have some injection strategies, right? Now this table shows you the physical properties of the hydrogen, right? Hydrogen fuel. The main thing is you want to concentrate here, right? The laminar, flame speed, and density, right? Now we compare here, right? The flame velocity is going to be higher for hydrogen when you compare to gasoline to methane. Similarly, the density is very, very low density for hydrogen. Density is going to be low. Therefore, we want a big tank, right? The tank capacity must be big to store large amount of fuel. Therefore, we are having less range of fuel in hydrogen fuel, right? Now, this is one type of fuel. Hydrogen can be used as gas. Now, the gas is filled in a tank. Now, this tank is connected to the intake port by means of a valve and by means of a pressure regulator. This injector is going to control by this ECU. Therefore, we are going to get combustion, right? This is a gas engine, hydrogen gas engine. Now we can have liquid hydrogen as a fuel as an internal combustion engine. Now the liquid hydrogen from this tank is taken by the liquid pump, and by means of this expansion chamber and H2 injector, we are going to feed inside the cylinder, and we are going to have combustion. And this is a liquid hydrogen engine. Now mainly we are going to see the ignition strategy here. Now we know what is HCCI, homogeneous charge compression ignition. We know what is spark ignition. The main difference here is pilot diesel ignition system and glow plug system. These two we want to see it now. Now here, this shows a pilot ignition system. Glow plug system. This shows a pilot ignition system, right? Now, as in the case of SA engine, right? In place of spark plug, now we are going to put a glow plug here. Now this glow plug is going to ignite the fuel, hydrogen, right? This glow plug is going to ignite the hydrogen fuel. Now what is the change in here is, here it is a dual fuel, that we are going to have some quantity of diesel and some quantity of hydrogen, right? Now by means of compression, we are going to get the ignition here, right? This is the pilot injection. We are going to have some pilot fuel diesel injection. By means of compression, you are going to get the ignition here. This is the main two difference in the hydrogen ignition system. Now we are coming to the last, the challenges and opportunities, right? When you take the alternate fuels, by means of blend, we can run the engine. What is the main thing is vehicle range is comparable with the conventional engine. We have positive here. Vehicle range is comparable, and the refueling time is also comparable with the conventional system. But the main disadvantage here is again the scarcity of the fueling station. Scarcity of fueling station is main disadvantage here. When you're comparing the cost, it is slightly more in a gallon equivalent basis. This alternate fuel costs slightly more. Now, when you're coming to the fossil fuel, CNG and propane, The main disadvantage is low range of the vehicle when compared to conventional engine. The fueling time may be comparable. There is no change in the fueling time, but here also the scarcity of the refueling station is the main disadvantage. Now, when you're coming to the cost, right? Natural gas costs less than gasoline and diesel, but propane costs more. This is the main thing. Propane is going to be costlier than conventional system. Now, next one is electrical vehicle. Again, the vehicle range is low when compared. Now, here, refueling. Electric vehicle refueling takes more time. It will take normally 4 to 12 hours. Therefore, this is the main disadvantage, main challenges we have. And also, we need a location, right? The location is also a problem. We need a big area, right? We want to charge the engine up to 12 hours, right? Therefore, when the engine comes inside to charge, it will going to stay up to 12 hours, right? Therefore, we need a big system. We need a large area of refueling station, right? But when you're coming to the cost, this is here, the cost very, very low, right? But the cost is low when compared to gasoline. Electrical LPG is going to cost compared to gasoline, right? Now, these are all the challenges we have. Now, when you're coming to the hydrogen engine, again, the range is going to be low. Why the range is going to be low? Coming here, right? The refueling side. Since the density is very less, we need a great tank, right? We need a great volume of the tank, right? That is not possible in our automobile. Therefore, the volume is going to be raised, the vehicle range is going to be raised, and also the fueling is going to be challenging, right? But the cost, when you're comparing the cost, hydrogen fuel cells, right? Fuel cell cost is high. Therefore, we need to have some opportunities here. We want to reduce the fuel cell cost by means of advanced material. Now, the last one, hybrid vehicles. Now, you see here, hybrid vehicles, the range is comparable, positive here. Refueling is same as conventional side, positive here. Cost is also low when compared to higher fuel economy. We are going to have higher fuel economy, therefore the cost is going to be less. The only thing is the vehicle cost, it is going to be higher. The vehicle cost is going to be higher. Therefore, now first stage we are moving from the conventional engine to a hybrid engine. Now most of our vehicles having this hybrid technology. Now this is the references I have made for the presentation. I have get the data, curves and all others from these references. Finally, thank you. And if you have any queries, okay. Any queries, please? Is it audible? Sir, is it audible?
Sir, PPT screen minimizing, sir.
Yes, sir, I minimized it.
Sir, chat box the questions irukku. You can verify the questions, sir.
Okay, sir. Okay, sir. I will check it. Sir, question from Saravanan. Sir, EGR is passed directly in intake manifold or other. Sir, EGR is directly mixed with intake charge. It is directly mixed with intake charge in the intake port. This is the answer I am given for Saravanan. And other question. Can hydrogen engine is used as fuel in existing CA engine without modification, right? This is a question from Virender Singh, right? You can use hydrogen in both the cell engines. You can use it in SA engine and you can use it in CA engine, right? Now I am showing you a dual injection, right? The dual pilot injection. Pilot diesel injection. Like that you can use it in SA engine. Right, this is the answer I am given for Virender Singh. Or any other question? Sir, any questions? A lot of comments. Thank you for all. Thank you all. Thank you all. Any other question? Yes, Saravanan is again asking a yes, sir, only reducing NOx is yes. NOx is mainly reduced, sir. NOx is the main parameter. Okay, then I will pass on the system to our organizers, right? Now this is in the screen you can see, right? Now this is my email ID and this is my mobile number. You can feel free to contact me on any time on my mobile and my email ID. Okay, sir. Organizers.
Okay, sir.
Once again, thank you for the. I'm hand over the session to the.
Once again, good afternoon to one and all. I'm very much happy to propose the vote of thanks in this wonderful occasion. I want to express my sincere, heartfelt thanks to our resource persons, Dr. G. KARTHIKEYAN, for accepting our invitation for this 5 days webinar series. Thank you, sir. Next, I express my sincere thanks to our management principal for giving permission to conduct this 5 days webinar series. Finally, I express my sincere gratitude to all participants. Thank you.
Okay, sir. Thank you. Thank you all.
Thank you all. Sir, thank you very much, sir.
Sir.
Thank you, sir. Thank you. Excellent presentation, sir. Thank you.
Thank you, sir. Thank you very much. Thank you.
Okay, sir. Thank you. Thank you, sir.
Shall I leave the studio, sir?
Okay, sir. Okay, sir. Yes, sir. Definitely, sir.
Thank you. Thank you very much.
Sister,